All right, this video is on Module 5, Topic 1, Lesson 2. And Lesson 2, we're actually going to skip Activity 1 and Activity 2. We're actually going to get right into Activity 3. And we're only focused on 2 pages, 690 and 691. And then we'll get to our assignment on 697. So we worked on our guided notes, that paper for volume of a cone. And we're just going to go through a couple of practice problems out of the book to kind of just reinforce our understanding. But this will be the last topic before our quiz. We're probably going to take it sometime next week. Okay. Now, before we start, I just want to write the formula for the volume of a cone. So I'm going to write it somewhere, maybe somewhere right here. Put V equal to. And just remember, the formula for the volume of a cone, it's a cylinder, which is pi r squared times h. And just remember, pi r squared is a circle times the height. And it's a third the size, right? It would take 3 cones, the volume of 3 cones. If you were to pour that like liquid of the volume of a cone, it would take 3 scoops to fill a cylinder with the same radius and height, with the same dimensions. So you could write it like this, or we could also write it like, we might see it like this as well. Whoops. Where we just have 1/3 at the very beginning. We're multiplying by it, and then it's pi r squared times h. Okay. They mean the exact same thing. Dividing by 3 is the same thing as multiplying by 1/3. But let's go through these problems. So, problem solving with cones. It says Joel owns a frozen yogurt and fruit smoothie shop. He just placed an order for cone-shaped cups, and the order contains 3 different sizes of cups. He wants to know each cup's volume to help determine how much he should charge, or how much to charge for each. So this is something that either entrepreneurs or people that own their own business have to figure out, right? They have to know how to price their items, because, right, if it's priced too expensive, then maybe people won't buy it. But if it's priced too cheap, then maybe people will buy it, but he's losing out on earned income. So you got to find kind of a good area there. Anyways, for number 1A, predict which cone has the greatest volume. Which one do you think will hold the most amount of frozen yogurt? So I'll leave it to you. Just put cone, whoops, cone number, you decide. Maybe we can look at our dimensions, our radius, diameter, or height, but I'll leave that for you. Okay. Number 1B, calculate the volume of each cone. Use 3.14 as pi. So I'm going to separate this because we're probably going to need some room here. I'm going to go like this and like this. We'll put that this is for cone 1, cone 2, and cone 3. We don't have too much room, so we're really having to squeeze it in here. So for the first one, actually, let me write down the formula first. So pi r squared times h divided by 3. So we have to have the height and the radius. We have the height here, 4.5. And here we're given the diameter, not the radius. So the radius, just remember, it's half of the diameter. So that's going to be half of 1.875. So let's figure that out. 1.875 divided by 2. Okay, 9,375. We're going to round to the nearest hundredths place for this. When you have long decimals, you can round. We'll choose the hundredths place. So that 3's in the hundredths place. So look at the thousandths place. It's a 7. That 7 will make that 3 go up to a 4. So we'll use 0.94, 94 cents. All right, let's write that in. Okay, and we're going to use these 2 pieces of information and for r and h in our formula. So let's plug that in. We're going to have pi times 0.94 squared times the height, which is 4.5, all divided by 3. Okay. Now here we have to always, our first step is to square our radius. So 94 cents times 94 cents. I'll put squared. 8836. Let's also round this to the hundredths place. This would be 0.88 or 88 cents. So let's use 88 cents there. All right, we're definitely gonna have to squeeze this in here because we really don't have that much room. So I'm gonna just rewrite pi. We'll put 88 cents without the square now because we already squared it. And my recommendation is now to multiply your numerators together, right? This is all a part of a group. I don't know why I highlighted it like that. All right, 88 cents times $4.50. So 88 times 4.5. All right, it's $9, or sorry, $3.96. All right, give me some time. My computer is a little bit slow. So 369 pi divided by 3. Now you can multiply $3.96 by 3.14, but what I like to do is, before I do that, is just divide it out. We'll use our coefficients, our numerical values. So what's $3.96 divided by 3? We could actually do that by hand because 3 divided by 3 is 1. 9 divided by 3 is 3. And 6 divided by 3 is 2. So this is 1.32, $1.32 times pi. So let's finally multiply 1.32 times 3.14. 1.32. All right. And we get 4.1448. Again, just keep going to the hundredths place. That 4 is in the hundredths place, the second 4. So we have $4.14. All right. 4.14. And our units were in inches, so this means that it's cubic inches. All right, let's circle this. Let's go through the second cone. So the second cone is kind of nice because we do have the height. It's a nice number, 7. The radius not a nice number, but we could still use it. 1.625. Yeah, we'll use that whole number. We'll use 1.625. Okay. So this will be V equal to pi times the radius, 1.625, squared times the height, which is 7. And then we'll divide it by 3. Right, 3 is always a part of the formula. But we're going to have to square this first. So 1.625 times 1.625. I'll just press the squared button. And this we will round to the hundredths place. So $2, we'll say this is 64 cents. 264. I know I'm saying dollars. It's not really dollars, but just so we can get an idea of what this number represents. 264. Okay. Big fraction bar. 264 times 7 divided by 3. All right. So as always, we're going to multiply our numerators together, or sorry, these two numbers in our numerators together. So we're going to multiply that by 7. I'll just put times 7. All right, rounding to the nearest hundredths place, it looks like this is 18.48. So $18.48. All right. $18.48. You know, I should have actually written that at the front. Let me rewrite this. 1848 pi divided by 3. Right, and just remember, you can multiply this by pi and then divide by 3, but I'm actually just going to divide by 3 starting out. And we can actually do this by hand. Well, we'll put this out to the side, actually. We can still do it by hand. It looks like it goes into it evenly because 3 can go into 18 6 times. It's evenly 18. It can go into 4 once. 1 times 3 is 3. 4 minus 3 is a 1, and then we get another 18 here. And as we saw earlier, it can go into it 6 times. So this is $6.16 times pi. So let's multiply 6.16 times pi to get our final answer in terms of cubic inches. Actually, I'm just going to give that to you. We're going to say it's V equal to, if you multiply it by 3.14, you're going to get 1936 cubic inches. All right, so I would say that cone number 2 is probably the biggest. It is, but we can see here, right? This is 19 point something, whereas the first one was 4 point something, so significantly bigger than that. All right, I'd like for you to figure out this third one as a U-do. So we have the diameter. Try to figure out what is the radius. Right, if the diameter is 5.2, what's the radius? I'd like for you to pause the video at this point because I'm going to give you the answer. But I'd like for you to try to figure it out first and then resume the video to figure out the answer. Okay, so I'm going to give you like 3 seconds before we write it down. Okay, so hopefully you had time to work this out, but the volume for this is 9.82 cubic inches. So $9.82. So we can see that the biggest one is cone 2, middle one is cone 3, and then the smallest one is cone 4. Or sorry, cone 1. Cone 4, I don't know what I'm saying there. All right. So we did A, we did B. We're actually going to skip C. This is just figuring out, right, what should we charge if we're trying to charge for the various amounts of yogurt that's in each of these cups. Okay, but we're going to move on to 691. So let's turn this over. So the last page that we're going to work on. We're going to do some U-dos as well. So some problems that we'll figure out, some other U-dos. Number 2. Mark and Allison work on their homework together and disagree on the volume of the cone. Mark is saying that the height is 8.2, 8 2/10 of a centimeter. And Allison is saying the height is approximately 6.5. Who's correct? Okay. So if we look at this cone, right, we have the radius, and the height has always got to be perpendicular to this. Now, what we have here, right, the height's got to be this right here, which we don't know. What we have here is actually what's called is the slant height. You cannot use the slant height to figure out the volume of a cone because that actually doesn't tell me the height. So we always got to use, right, perpendicular or at a 90-degree angle, right angle to the radius. But hopefully, like, if you're just if you're kind of ignoring the whole shape of the cone, right, this right here is a right triangle. And if you remember from right triangles, right, we can use the Pythagorean theorem to find a missing side of the right triangle. So we're going to use that here. Right, in the right triangle, we have a squared plus b squared equal to c squared. We have to figure out which one is c. C is the hypotenuse, c is the longest side, is always opposite the right angle. So c is 8.2. So let's use the Pythagorean theorem formula. It doesn't matter which one 5 centimeters is. I'm going to make 5 centimeters b. So we have a squared. We'll say that that's the height. 5 squared equal to 8.2 squared. Okay. So we're going to have a squared plus 5 squared is 25. And then 8.2 squared. Just going to do that on my calculator on the side. It is approximately 67.24. Right, for solving for a, we're going to subtract both sides by 25. I'm going to put 25 right here because we're going to line up the decimal, and the decimal is at the end of the 25, is at the end of the number if you don't see it. All right, 24 cents minus 0 cents is still 24 cents. 7 minus 5 is 2, and 6 minus 2 is 4. At this step, we'll take the square root of both sides. Right, and just off to the side, I'm just using my calculator here. A is approximately 6.5 centimeters. So that is our actual height here. 6.5. Okay, so going back to the thing, to the situation here, it's Allison. So Mark thought it was the slant height that represents the height. That's not the same thing as the actual height of the cone, right? That's kind of like a ramp on the side of it. But Allison is correct. Okay. All right, let's go on to, oh, sorry, this is supposed to, calculate the volume. I'll leave this as a you-do. So now using that as a height and 5 for the radius. Let's work on numbers 3 and 4. We're gonna work on one, and we'll say the other one is a you-do. We'll say this is the you-do for this one, and we'll work on this one. And the number 4, really, it's the same thing, except you don't have a diagram. Well, and we're trying to find this other height, or sorry, this other measurement. We'll say that the A is the you-do, and we'll work on B. So we're gonna do B for both of these. All right. So for this one, we're trying to find the volume of the cone. The height here is 7. The radius, well, if the whole diameter is 4, that means the radius has to be 2, so divide it. Okay, let's plug this all into the formula for the volume of a cone. I'm going to rewrite it just so we understand. The radius is 2 squared times 7 divided by 3. Okay, let's do this first. 2 squared is 4. And then 4 times 7 is 28. So we're going to have 28 pi divided by 3. We can do 28 pi, or sorry, 28 divided by 3. So 28 divided by 3. Oops. All right, it's 9 and a repeating 3. So we'll say $9.33. Round it to the hundredths place. So 933 pi. So let's multiply this by 3.14 to get our final answer. All right, looks like this is $29 and like 30, but the 6 makes this 30 at 31. So $29.31. $0.31. Okay, great. Now we don't. This is actually in terms of dollars and cents. It's in terms of centimeters. So this is how many cubic centimeters we have, or centimeters to the third power, centimeters cubed. Okay. All right, but hopefully you worked on number 3. 3A. I'm just going to give you the answer for 3A. It's 83.75 cubic centimeters. All right. Now, notice for number 4, we're not trying to find the volume. We already have the volume. So what I'd like for you to do is set up the formula, but now in this case, you're trying to find the height. But I'm going to figure out the radius for this one. So we have the height, we have the volume. We just got to figure out the radius. So let's use our formula. Always start with your formula. This is something that we did in our notes. So we're saying that the volume is 25 pi. So let's plug that in for V. 25 pi equal to. We have the height is 12, but we don't know what the radius is. So I'm still going to keep this as r squared times 12. Okay. So we can do this in a variety of ways, but I'm going to get rid of the fraction. We're dividing by 3, so let's multiply both sides by 3. 25 pi times 3 is 75 pi. I'm going to rearrange this. I'm going to put the 20 or the 12 in front. So 12 pi times r squared. And just remember, right, you can divide both sides by 12, see what that equals. But I'm going to divide this by 12 pi. And if your answer is not in terms of pi, divide it by 3.14. But you can see we're going to get rid of this, get rid of this, get rid of this. Let's figure out what 75 divided by 12 is. .25. So we're going to get 6.25 is equal to r squared, but we want to find the radius, so we got to take the square root of that. So square root 2.5. So this is 2.5 inches is our radius. Okay. All right, great. So let me know if you have questions on your UDO. I will say for UDO, a little bit of a hint, it should be smaller than 20. So bigger than, it's going to be in between 10 and 20. So if you don't get a number between 10 and 20, let me know. All right, but we're actually going to skip these pages. Let's get to our assignment. All right, here we go. So our assignment, we're going to just do numbers 1 and 3. So all of number 1 with its various shapes. So 4 problems there. We're going to skip 2 on the backside, and we're going to do 3 on the backside as well. And just a little bit of a hint on number 3. Right, work your problem as you normally would, but this wants to determine how you're working with cubic inches, but they want to figure out what it is in terms of cubic feet, and we know, or the fact that they give us is 1,728 cubic inches is 1 cubic foot. So pretty much what we want to do here, work it out like you normally would, but your final step, divide by that number, 1,728, to get this in terms of cubic feet. Sorry about that. All right, let me know if you have questions. Let's get started.